Hello, this is the intro to CloudEvents. We're part of the CNCF Serverless Working Group that's working on a standardization for something called CloudEvents, which we'll teach you about right now. I'm Scott Nichols from Google.
And I'm Klaus Deissner from SAP. And before Scott later on will go into more details with actual coding and also a demo, I will give some background of what the Serverless Working Group is actually doing and how CloudEvents were started. So the working group was established in the middle of 2017. And first thing that was done is to create a white paper to determine what is actually serverless. It was a floating buzzword at the time. And also to come up with recommendations what CNCF could do with regard to serverless. And in parallel, also the serverless landscape was created to show all the players in this field. And one of the first recommendations was to look at events. So pretty much all the function frameworks that were around at that time took event as one of the input parameters. So there seemed to be something about this eventing stuff. So CloudEvents was then established as a sandbox project about a year ago. And another activity that was happening was to create a spec for function workflows. So let's start with eventing. Actually, when I joined this working group, I was first wondering why are they so interested in events, and had to recall what I learned maybe earlier on. And I at that time knew events mostly from things like UI frameworks, where you get those button-clicked events and write event handlers. And we had some more formal definitions for things around events. So it all starts with a so-called occurrence. That just, basically something happens somewhere, so it captures the statement of fact, and in our case it's usually related to software systems. From that, then an event is created, which is a data record, and usually you do this, of course, to trigger something, to trigger an action. But the most important thing here is that the occurrence is actually decoupled from this action. So it doesn't really know and shouldn't really care if any action is triggered by the events it's emitting. And so in the UI frameworks I referred to before, event is just something like a plain old object, and the handler may be just an interface implementation. But how does this look like in distributed systems? So I just picked one example, and so what you see here is you have a message broker in the middle that is providing the technical decoupling, so routing messages between different participants. Usually something like a pub/sub schema is used for this. And on the left-hand side there is an application that may be emitting some events depending on the domain of that application, something like an order approved or something like this. And there are on the right-hand side, there's a function. I mean, after all, we are the serverless working group, so a trigger is there defined to trigger the function based on certain events occurring. And there may even be function workflows, and of course the state transition in the workflow is usually triggered by an event. And of course there may also be some cloud offerings, and it's well known that they also provide usually webhooks notifications, and so the webhook endpoint here is then providing as a bridge between this webhook notification and the message broker. And so what can now the CloudEvents and what we are doing in the Serverless Working Group do for you here? And first of all, we have transport bindings for several messaging protocols. So this part of transporting events between the different participants in this distributed system is covered. We have, of course, also bindings for HTTP in several flavors. And it's not just about, what we achieved by this is that we can transport events in a uniform way or over several hops. And the benefit here is that we have this unified event context. And this can then be used for things like filtering, routing, or subscription handling. And although we in the working group do not define how exactly this filtering or routing has to happen, that's then implementation specific. But the idea of the event context, this unified context, is to really enable those things. A bit independent from the rest of the spec, we also have a specification for webhook delivery. So how exactly some events can be delivered via a webhook, like protecting the sender against some abuse and things like this. And then there are the workflows that make use of the event definitions for state transitions. And last and certainly not least, and we will see later on a bit more about this, are the Cloud Event SDKs. So after we had some draft of the specification, also the SDK work started. We are supporting several languages already. And this enables then developers in all parts of this distributed system to work seamlessly with cloud events. And one other important aspect here is that all those components seen in this picture might be provided or operated by different parties. So interoperability in this whole game is really important. So what are cloud events? Cloud events are just a minimum set of attributes. So they are listed actually here. Just the first four in bold letters are mandatory attributes. And so you see it's really about not putting too much information in this event context. And then there are several optional attributes which are actually also quite useful in many cases, like the subject that recently was added, or timestamps. You can always make always good sense, I think. Or a schema URL that might point to a JSON schema document for the payload of an event. And at the end, there are also ways to extend the whole thing and add your own attributes. We also have a certain set of well-documented or known extensions, and where we think that they might be of general interest, and we want to watch if they get more adopted, and if they are widely adopted, then we might even think of adding them to the standard later on. And for all this, there are transport bindings. Here it's listed JSON, HTTP, and MQTT. We also have AMQP, protobuf, and NUTS, I think. And so quite a few already, and I think this is even growing. Some principles I observed over the discussions in the group are that transport bindings are not supposed to be another communication layer. So the protocols that are used for eventing are already layer 7 protocols, and adding layer 8 doesn't really make sense. So it's more describing how to use those protocols to transport events with the primitives they already provide. Also things like batching of events, if the underlying protocols already support that pretty well, like for example AMQP, that's not really the concern then of the cloud event standard. Context attributes, I mentioned already that less is more usually, so the guidance is here to have as few as possible, but of course as many as needed. As they are put into things like the headers in certain protocols, it's really important to think about the cost of transporting all those attributes. And if there is really the need to have them in the event context, or if they can also be put into the payload of an event when they are just used in the event consumer and do not really provide additional use for intermediary hops for the event. It's important to mention that event attributes should also not contain confidential information. As the event context is used for routing, it's not really feasible to do end-to-end encryption for this part. The payload, in contrast, should be encrypted, or it would be good practice to do so. And I mentioned it before, but I think it's important to emphasize the goal really is interoperability.
Sorry.
Yeah, this one. So a few things that happened since we finished version 0.2. We added the subject attribute as we realized that putting everything where the event came from and how it was emitted into a single source URI is sometimes a bit well, cumbersome, I would say. So we separated this. So the source is now about the context where the event occurs, and the subject is more what it's related to or what, yeah. And content type was now renamed, the attribute to data content type, to avoid misunderstandings in certain cases where you have content type in the header and the data content type in the for example, in the JSON format. We have some new documented extension, the data ref, that's supporting the claim check pattern, where you do not send the actual data as part of the event, but just a link to the data to avoid a huge data transfer and also to enable some kind of authentication authorization for the receiving end. And we discussed things like batching, and what I said before, that batching is not really to be handled by CloudEvents, but by the transport layer. And but for HTTP, we needed some solution, and there we defined a way to do batching with HTTP plus JSON by basically introducing a JSON array for events that could be put into a single HTTP message. So I think with this background, now I hand over to Scott, and now it gets a bit more practical.
Thanks, Klaus. I have a mic.
Ah, yeah.
Okay. Who in the room knows Go? If you don't, it's similar to Java or C++. So we're going to do a little bit of fun. So let's see. I already wrote the code, but I'll walk through it. This is using the Golang SDK for CloudEvents. You can find it in GitHub/CloudEvents/SDK-Go. In my day-to-day work at Google, I work on Knative eventing, and we use CloudEvents internally in Knative. And so we had a library, and we upstreamed it to the CloudEvents org. And so I'm going to show you an example of running this. So here is a simple example. The payload will be this simple struct that's just a name in the data. And I can use this method called new default client, which I can show you. All it does is says you're going to use HTTP as the transport. Oh, actually, I'm sorry. Before I jump into this, I made a pretty picture for you. So this is the outline of what this SDK does. The main wrapper is this client object, and you give it a transport. And because the transport has a set interface, the client doesn't need to know how the data is going to be sent on the wire. That's the little radio icon. The transport encodes its own codec. So I've kind of decoupled the cloud event as the piece of data and the on-the-wire representation for the transport. So the transport's job is to, if you send an event, a cloud event object, it goes into send, it goes into the encode, and it goes out the wire. If an event comes in on the transport, it goes into the decode, turns it into a from a message to an event, and then it gives the transport receiver that new event. So your function gets activated. So I'm going to show you this in practice. Yeah. So I'm going to run this person. So new client, cool, we have a CloudEvents client, and then I'm going to say start receiver. I'm going to give it a receive function, and it can be several different things, because I do some magical reflection. But the one I'm going to choose is I get an event, which is a cloud event. Okay, and then right now you say, I have a struct. Please turn the payload into the struct that I know. It does some magic marshalling thing. And then I can print out my name, hello, whatever, right? Hello world. Okay, so we're going to run that. And so it's the person, main. It's super. And I have a little curl command that I can copy. So we're going to curl URL, and we get an event translated into the kind of this transport in specific version of that. So you can see the context attributes, the routing information that you could use if you're in a bigger system, and then the data payload, which in this case was this is HTTP binary mode. It shows the payload. Okay, cool. So let's say you would like to send data to that. I'm doing some magic here, but I make an outbound HTTP transport, which means I'm making a CloudEvents transport. I give it a target, which there's other ways you can do this, but it's okay. And I'm saying use binary encoding for sending. And then I give that to a client. Note that I'm using a different method. This one actually, you provide the transport instead of having the same default, which is normally HTTP. Okay, so I have some magic methods that do things like defaulting UUIDs. Basically it says like if the context isn't null and the ID isn't set, just make a new UUID. It's kind of some convenience methods there. So we are going to run this, and all it does is says client.send, the event we just constructed. All right, so hello, Barcelona, and the name is Hannah for HTTP. So let's run that. Oops, wrong demo. So that is the greeter. And so that has sent a message over HTTP from one thing to another, right? Okay, that's cool. But you're saying, well, I don't really use HTTP, I actually use NATs. Okay, so I can do the same thing where I make a new NATs transport. I have a NATs server running locally on my laptop. I set the subject as hello, and then I make a new client, the same method. So I've constructed that transport and given it to the CloudEvents client, and now I can call the same method, the start receiver method, and I give it a function here, and it's going to basically do this exact same thing as the other one. Right? The difference between a NATs person and a person is just the fact that I'm not using the default client. So we'll run that. So it's starting, but I don't know how to curl NATs. So I can change the greeter to use the NATs version of the transport, which is exactly the same. I set up the transport, I return it back. I'm panicking for demos. This is not production code, don't do that. And I'm using that same thing, but we'll do 8. Okay. And then we run the greeter again. And so we get Nate. And we can still curl URL. Okay. So now that you have this kind of fun dynamic where you can inject the transport, I realized you can do other fun things like I can make an inbound NATS, an inbound HTTP client, and then an outbound client, and I can choose the transports that go in those things. So I'm giving NATS, I'm going to listen on NATS and HTTP, and I'm going to make a forward function, which is just going to use the outbound client to send the event that it received. Okay? So we're going to start those two things up, and then block. And the magic to make those two transports is here. Okay? So that's the forwarder. Oops. Okay, so it's going to do its thing, and then watch this window here. We can still curl URL. We can send the greeter. The greeter is still running NATS. So this has gone 2 NATS through the forwarder via HTTP to the original hello person, right? But we can also, we can change this back to HTTP. Okay, so now we're using HTTP, and we'll send it again. It's going to be, well, and so now it's done the same thing. The HTTP receiver and the forwarder has picked up that event, and it's sent it on. Oh, actually, the forwarder is listening on 8181. So we need to change the greeter to listen on a different port. Okay. Why? Ah, right. What file am I in? Yeah, that's right. Okay. Come on, greeter. Well, I don't know. Demos. This is the outbound target. Yeah, you're right. You're right. Thank you. Thank you. Let's change that. Give this guy a cookie. Awesome. Thank you. So now we see that the event is going through the forwarder into the other HTTP. So this is interesting. I mean, it's not very interesting on my laptop because it's not that cool, but I used this technique in the next thing we're going to talk about in a minute, but we'll get back to that. Okay, so everyone have a phone? Everyone get ready? Do you have a QR code scanner? So again, so the transports that we support on the SDK Go library is AMQP, HTTP, and NATS. If you would like to see the code or the other SDKs, they're not all as opinionated as this one. They don't all have the client and the magic, but maybe one day they'll all get there. Okay. So we the CloudEvents working group, have been working with somebody that's working with the Heathrow Airport to simulate like what if a big complicated thing like an airport had all of the entities sending cloud events to a central hub so that you could watch those events and respond to it. Maybe something simple like some room continues to be hot and so there's probably a broken AC piece somewhere. And maybe that data needs to filter up to some central place. That's the eventual goal, and to make it interesting, we built a little demo. And if you would like to scan this code, we'll get the demo up and running. Okay. Everybody ready? Okay. So what's happening is all of our partners have produced a little microservice that goes and services you coffee, right? So you're selecting coffee. That causes an event to be placed on the central bus. That coffee barista will serve you a coffee, and then you'll eventually run out of cups. And then one of these trucks will go and deliver the supply from a warehouse back to the barista. So, okay, let's make it bigger. Come on, Knative, you could do it. So the thing that's interesting here is that we're all talking over a central bus, which is AMQP, but every new logo in this picture is actually in a different cluster somewhere else on the internet. And they're all bridging AMQP, but that's only on the outer pieces. So for example, Knative takes AMQP and uses basically that same forwarder code and says AMQP to HTTP, and I send it to some internal details of what Knative uses. And there's other talks that talk about that. Everyone is using a different transport to communicate internally, which is kind of cool, but we all have that same core piece that is the cloud event. So we all know and understand how to route pieces to each other without having to share the transport details, because we've all agreed that we can use the cloud event spec to translate between different transports, which is compelling. So, come on, whoever's ordering coffee, pick your cup. Okay, so this is the demo. It's a bunch of people collaborating over a central bus, responding to events, and then the demo. Does anyone have any questions? The question is, am I lying about the central bus? We've all agreed to speak together on one central AMQP channel, but internally there's probably as many queues as you see representations here, because everyone internally can pull messages off that central bus and then distribute internally, whatever that means. And like Knative is all written in Go. I know that the function framework from SAP is written in JavaScript, right? Like they actually bridge from the AMQP into an HTTP. They get invoked via HTTP, and then it's a JavaScript function. I'm sure the Microsoft thing is in C#. Doug is Go, okay. Got a little bit of Node in there too. Got it, yeah. But so anyway, we're trying to show that you can mix languages, and you can, whatever your proficiency is, shouldn't block you from also working together. And the goal of Cloud Events is to make sure that the transport is agnostic to your goal. So hopefully that's what we conveyed. Any other questions? Did I answer that? Yes? Yeah, it is. I'm going to be biased, and so in the Knative project, we actually have something called a source that listens. You can register for events of a certain type, and then it will do a watch for you, and then turn that into a cloud event, and then route it to a destination for you. And I guess technically it could be off the cluster because it's just a URL, but somebody is maybe going to talk about a serverless reconciler for Kubernetes using CloudEvents and Knative. So yeah, I don't know if we're going to upstream that stuff, but Knative has been building adapters, and I think various other companies as well, where you turn something like a GitHub URL or a GitHub event into a cloud event, and then that helps the internal routing mechanisms, because it's difficult to understand what just random JSON is. So, does that answer it? Okay, got anything else? Sarah.
So have there been application level events that have been adopted? Are there people who are making these semantic events on top of the platform yet?
For Kubernetes, or?
I mean, it's sort of independent of where it's deployed. I think that it would be, as a kind of an application developer, if I could subscribe to, if I knew that there were payment events that came from multiple payment issuers, that would be a neat thing, right? So that's where it sort of starts to be not a central cost technically, but there is a vocabulary that people can know that this format is coming out of multiple vendors. So I'm just curious if we're there yet.
So yes, it's up to you to code that, and we're still CloudEvents is still getting worked on. But not to plug my own code again, but there's an organization on GitHub called Botless, which was a demo thing that I wrote for KubeCon China, and it uses CloudEvents and Knative to bridge multiple chat devices and then translate that into a bot command, and then that gets invoked, so you can actually wire up as many different chat services as you want, and maybe different command types. And so you get this, because I'm using CloudEvents all the way through, I have these little filter functions, I can turn it into the same shape and then invoke on the same command, but it comes from different areas. So it's a very interesting eventing thing happens. What is happening? Who's this guy? Is it you? Anyway, does that answer it? I think we are. I think it's. Yeah.
That's the next step now that the protocol is getting interoperable across
the fact that you don't have to worry about the transport is really compelling, because I can write my application. I can use HTTP locally because it's super cheap and fast, and I can use curl or whatever, and then I can deploy it into production and switch it out for NATs, or I can switch it to AMQP or whatever other transport that you want to use in production. And I know that the function that the event that comes through that system invokes my function the same way, and I don't have to think about the transport or the signature of my method. So we're standardized that piece. Oh yeah. So you can also click on it if you go to the view page, but we're showing you what the raw cloud event looks like. And so here is the context attributes. Depending on the transport, they get wired up to different places. So for binary mode on HTTP, it's part of a header. You could also have it structured mode, where it would look like this as the body of the HTTP. In AMQP, it gets mapped into headers, and the payload becomes mapped into the data body. So in every transport, the mappings is a little different, but because we've agreed on how to translate those two things, you end up with the same object, and you get to work with it. Yeah. Well, thank you. I think we're out of time.